Hi, Alan Stratton from woodturning. We had a demo on baby rattles at our club meeting last month. The demonstrator did a good job, but one thing he did not clarify was the regulations surrounding baby rattles. And I think there's a lot of confusion out there about the regulations and some bad information and potentially some denial as to the applicability of the regulations and the consequences thereof. Well, to start with, some people say, well, okay, for the choking hazard, they use a toilet paper roller as a guide. Well, for a small parts, that is close, but in reality, this is the spec of the regulation according to section 15.01. If a part fits entirely inside this cavity, which is a cavity with a slant portion in it, then it is too small to be considered. So if this is the guide, then, well, this would not pass. However, this does pass. Okay. But there is another regulation, section 1510, that talks specifically about baby rattles for children under 3 years. This is the test fixture, and any portion of the rattle cannot penetrate clear through this. So it's a different test, different intent. So in this case, here's a handle that could work under the old regulation, old style for this. But if you put it into this, whoops, some portion of it penetrates through. Therefore, this would not be compliant to the regulations. Not to be forced, but it, at an angle, it protrudes, so this fails. However, this one, if you put it in at the most adverse angle, does not protrude through, therefore this one passes. So, well, it is bigger than that, smaller than that, bigger than this, so yes, it's compliant there, and yes, it is compliant there. But let's have some fun with the tired old subject, and let's make a rattle with Celtic knot in it, and have some fun with it. After all, we've got to be creative, even if we are compliant with regulations. But one more thing, some turners actually go so far as to say mine are for ornamental only, and therefore the regulations don't apply. That is extremely dangerous turf. From the regulator standpoint, if it looks like a duck, walks like a duck, sounds like a duck, it's a duck.
To review, I have created the 3 rules for Celtic knots. If these are followed, Celtic knots look great. Most Celtic knots that you see use square stock to adhere to rule number 1. However, square stock limits the Celtic knot to 2 or 4 loops and does not help with rules 2 and 3. In the following project, you will see a process that adheres to all 3 rules and can produce any number of loops in a Celtic knot. This project uses a table saw. I have also adapted the process to enable larger diameter projects using a band saw. For this project, I selected a piece of wood that I believe is some species of maple. I rough-turned it to a cylinder about 2.5 inches in diameter. My saw can go to a 3-inch diameter. In previous Celtic ring projects, I printed patterns that I glued to thin plywood for templates. This time, I decided to 3D print the templates and a spacer disc. This template accommodates a 2.5-inch cylinder and 3 or 6 loops. Different templates enable different numbers of loops. I screwed the templates to the end of a cylinder using center marks. A small dab of hot melt keeps them from rotating. To maintain stock orientation for sawing and gluing, I hot melt glue scrap wood, in this case OSB, to the top of the cylinder. This application of scrap will be repeated for each cut. To perfectly repeat the saw cuts, I hot melt scrap wood to a sled. The angle selected for this project is about 23 degrees. In use, the templates on the end provide the rotational angle The scrap on the sled provides repeatable cut angles. The spacer that you will see shortly provides an offset for a kerf wider than the saw blade. For the first cut, I set the saw blade to cut through the cylinder, but not through the scrap at the top. I am careful to mind where my hands and fingers are while I hold the project wood to the sled. A box at the back of the sled encases any portion of the saw blade. Now it is time to glue in the insert. I always use 30-minute epoxy. When I do this demo live, invariably someone asks why not 5-minute epoxy or wood glue. Well, it takes time to mix and spread the epoxy, especially to apply it to the interior of the saw kerf. 5 minutes is way too tight for me. As for wood glue, I used it in my first projects but switched to epoxy when the glue seized while I was inserting the wood into the kerf. I could not budge the wood to be fully inserted into the cut. In the end, the rub joint techniques works for segmented gluing but not for Celtic knots. I need the time. When making a Celtic knot, I like to use a cylinder twice as long as I think I will need to make 2 knots while I'm at it. So after one cut, I add a spacer to widen the kerf, then rotate the stock end for end and do it again. Back to my glue station for round 2. By the way, the clamps keep the wood insert from moving until the epoxy hardens. Otherwise, it has a tendency to slip inside. My gloves do double duty to protect the clamps. While we are talking about gluing, some parchment protects the work surface, a digital gram scale to accurately weigh the epoxy proportions following the manufacturer's guidelines, disposable food service gloves, epoxy mixing stick, disposable mixing container. Back to the saw to make cut number 3. Pretty much the same deal. After the first cut, I used 2 pieces of scrap with a bit of space between them for better stability. After each kerf glue is hard, I clean off the scrap and trim back the excess wood from the inserts. For hot melt glue, denatured alcohol helps. For the epoxy, I trim with the bandsaw, but be careful. Finally, back at the lathe with the templates removed, I can clean up the surface. More importantly, cut mounting tenons and measure out the length I need for this project. Now to turn the Celtic knot. First, reduce the diameter to a target of 1.5 inches, then mark the extent of the loops to see where it is happening. Then use some of the measures for an octagon method, but adjusted for an egg shape. I figured the big end of the egg to be a hemisphere, but the little end will be by eye, with a target of the length being 1.4 times the diameter. At least, that is my preference. Your chicken will probably disagree. After marking the cylinder, I trim for length, then the big end diameter, then some by eye, but before going any further, I want to drill the interior at 3/4 inch diameter for the initial hollowing. As I start hollowing, the wood shears off at the bottom. Ooh, this is not supposed to happen with spindle projects. It appears that the grain is wild. It is a clean shear. Bummer. Fortunately, the wood I left at the base is enough to fit a smaller chuck using the hole for alignment. I go for it again, but it quickly shears off again. Double bummer. This is getting serious. There's no more wood for a tenon. This time, the whole leg will be the tenon, again aligned with the interior hole. Now the problem is to finish the exterior, then sand the exterior before finishing with my mix of beeswax and mineral oil. The handle is Fetzer, which smells somewhat like cedar or juniper. I need a 3/4 inch tenon to fit the mortise in the egg. After making the fit, I can move on to cutting the handle portion. Before consumer product safety regulations, this would have been a handle like a finial. However, that will not fly. I cut the first inch of the handle before sanding and finishing this section. Now for the extreme end of the handle. I'm counting on a disc shape at the end to conform to the rattle choking regulation, paragraph 1510. But we'll see. I do not want another sphere like the Celtic knot end, but if the disc fits sideways through the test fixture, there will be trouble. It passes the test, and I go ahead with the final finishing.
So with the rattle complete, it's hauled out, ready for a noisemaker. I'm going to use popcorn kernels, can put in several in here, not so many as they are too tight to rattle. And then all I'll need to do yet is to glue in the handle. There's my baby rattle, compliant with the regs. Here we go, we did it.
Please give this video a thumbs up and subscribe to my website as well as on YouTube. Please spread the word by telling your friends about my weekly videos. I also appreciate your comments and questions. Please wear your full face shield whenever the lathe is running. I hate to nag, but are you wearing yours?